So let's just talk about different ways we can create arrays using Numpy in Python. So as we have talked about earlier, Numpy is a package and it is mainly used to create multi-dimensional array and also for scientific computations. For now, we're just gonna focus on creating multi-dimensional array using the Numpy. So the Numpy has several different methods that we can use to create arrays. So first of all, we have to import Numpy. So we're gonna import as np. So instead of Numpy, now we can use np to use all of the methods. So first of all, let's just talk about the array method. So this method is basically used to create arrays from a list of numbers. So we can create the array. So we have to write np.array method. Now here inside we're gonna pass one list and we can pass list of numbers, and this will be converted to one single dimensional array, and then we can just print that. So here we have the single dimensional array. Now in this array method, if we accidentally put some different data type, Numpy will automatically determine the type of the data, then it will be automatically converted to make sure all of them are of the same type. And next we have the method Linspace. So the Linspace method is basically used to create arrays where we're gonna have evenly spaced numbers over a specified range. Like an example, so we're gonna create this array. So np dot linspace, it will take 3 arguments. So first one is the starting point and then the ending point. Now the third argument is where we can specify how many points should we have in between the starting and the ending point. So let's now create 5 points. That means in between the starting and the ending point, we're gonna have 5 evenly spaced points. So let's now print this. So here you can see we have this array. So you can see from the starting and the ending point, in between we have 5 evenly spaced points. Similarly, also we have the method Logspace. So this is also similar to the Linspace, but here it spaces numbers logarithmically. Like an example, we can create array, and here we are gonna use np.logspace. Now it will also take 3 arguments. So first one is the starting point, then the ending point, and then the number of points we wanted to create in between. So let's now create 5 points, and let's now print our log spaced array. So here you can see we have this log spaced array. So from the starting and ending point, we have 5 points in between them. And next we're gonna talk about the Arange method. So this is similar to the range in Python, but here it is used to create array. We're gonna create the array. So np.arange. Now it will take 3 arguments. So first one is the starting point, then the ending point. Now we can specify the step size of the range. So here we wanted the step size to be 2. That means from the starting point we're gonna increase with the step size of 2. So let's now print our. So here you can see we have this array. So this is the starting point, and you can see the gap between the data points are 2. So from the starting point with the gap of 2, it will go till the ending point. And also we have the zeros method. So this basically used to create array which is filled with zeros. np.zeros. Now here it will take the argument. So we want the array to have 5 zeros, and also we can define the data type of the array. Use the data type as integer. So this will be one integer array which will be containing 5 zeros. So if we print this, so here we have this array which contains 5 zeros. So let's now talk about the ones method. So this method will create array which will be filled with ones. So we're gonna call the method np.ones. So the array will have 5 ones, and then we can mention the data type. So we're gonna make it integer type. So this method will create one integer type array which will be filled with 5 ones. So let's now print this. So here we have this array which contains 5 ones. So this way Numpy comes with so many different methods that we can use to create and manipulate array. And also Numpy is essential tool for scientific and numerical computations. So that's it for the video. See you in the next one. Take care.